current kind of imaging that's happening with the brain. So this one is a composite image. Now, to orient you, the image on the right, if you think about a sort of a boxing glove like that, can you see that sort of thumb piece and the round bit? So that's my brain like from here. So that the front of that picture is the frontal lobes and the back is the occipital, so near the occiput. And then where that thumb kind of piece is the temporal lobes.
So temporal where?
Temple.
Temple. So that thumb bit goes here.
Yeah. So it's not, and it's not really like, it doesn't look like a thumb, but yeah. So now the tracks that you see, so the little kind of pieces of wool are axonal trajectory. So like I've talked about neurons, each neuron has a fibre that comes into it, sort of its receiving fibre, and the fibre that comes out of it. I'd never called them a fibre before, but anyway, they're projection. And they bundle together. So they're like, you can get like a single road with one neuron, or they bundle together to like be a highway. And these are kind of super highways connecting different bits of the brain. So can you see what the first thing you see is this brain is highly connected. Now, if you look at sort of, if you're a network analyst person, you would look at that network structure and say that is not a hierarchy, right? It's not a hierarchy. You cannot see a hierarchy in that pattern. So the tracks, whole brain axonal trajectory they're called. So it's the one on the side is looking from the side. The one on the left is looking from the top. So you see the left hemisphere and the right hemisphere. And can you just see there's a whole lot of in between. You can just see like the two walnuts. There's a whole lot of lines going horizontal. So that's the corpus callosum. That's what connects one side to the other. Then the colours are basically green. Anything that's sort of in the green spectrum is going front to back. Anything in the red is going across. That's why you can see the corpus callosum is more red. And blue is head to tail or tail to head, right? So top to bottom, bottom to top.
How do you know that?
Because it says at the top. No, that's no. Sorry, that was a really cheap shot. No, that's the way they do it, so that we can interpret. And then the shades, so that you can see that most of them actually.
Sorry.
Oh.
Like, how do they know?
Oh, how do they do it? So.
Sorry.
These pictures are built up from a composite, and one of the techniques is called diffuse tensor imaging, DTI, and they do this weird thing. They'll seed an activity in one region of the brain and then see where it flows to and how strong the flow is, so to speak, that they pick up. And it's done in a functional magnetic resonance imaging unit, same as a normal fMRI that normally just shows you regions. So this is the change. Instead of looking at the geography, they're looking at the connections, because that's.
You say top to bottom. I'm thinking spine.
No, but top to bottom in terms of the brain.
In terms of the actual structure. This
is only the brain. All right. So there's actually, the top to bottom. There's nothing that's really, really blue. It's often more purple. And so the shades show you that it's nothing's particularly planar either. You see what I mean? It looks. Can you see there's an order in there, but it's also not hierarchical. It's not like the front is dictating a lot to the back, right? So you can look at it very simplistically. I think they're beautiful images. Pardon? Yeah, so looking at the top of the brain, so the front is the frontal lobes, the back is a more sort of the visual area. And across the top, so if you think about this sort of headband thing, it's not that, that's where the motor area and the sense of primary motor, you don't see those regions because everything is so connected. So you don't see regions, you don't see a geography there because it's so connected. Everything is connecting to, you can't say everything is connecting to everything. You'd have to say there's a lot of networking, right?
So is this someone at rest?
This is a composite of that sort of done a whole series of functions and made a composite. So if... Sorry? There's not one function. This is not imaging one function. This is a composite. It's a composite of functions. So they've got a lot of different functions. So speaking, moving, thinking, seeing, sensing, everything. It's a composite of functions.
So they want to see how much of it lights up and how many different connections. connections.
This is a composite of the connections of a whole composite of functions. Yeah. Yeah.
To just demonstrate how we connect.
Yes. Yes. So yes. Yes.
Yes.
Yes. Yeah. Well, you can look at the brain morphology like that if you want to. It's just another way of looking at the brain. It's another way of looking at it. Yeah. So your wish is my command, Martina.
Your old baby.
So that's a more simple version. That's looking at a slice through the brain, looking at. So if I sliced it down that way, so you can see. I just like that image because see that U-shaped business. That's the corpus callosum. Right. So this is actually sliced through, sort of between the primary sensory motor cortex straight down. So again, you could say, all right, well, up here, all that kind of neocortex up there, that's very human, and here's mammalian, and here's reptile. But again, you can say, well, it's pretty integrated. Like if we're going to look at the species, we're pretty integrated. And my objection to that is that a lot of the emotional stuff and the memory stuff is in the so-called mammal lower brain. And I think our memories are very sophisticated. And I think our emotions and the connections and all our spatial memory and all this sort of stuff, it's very sophisticated. And I'm loath to say it's mammalian. It's mammals don't do what we do with their emotions. So anyway, we're very integrated. So here's just some sort of very, very super highways looking around. So here's sort of more limbic system stuff happening. But these are more connections between, say, legs, for example. These are big tracks that come down from the motor cortex down to tell us sort of the final motor pathway. But there's a lot of loops within as well, so bits of the body communicating, as it were.
I imagine people would have different, sort of like generally similar things, but basically it would wire itself differently according to what that
Slightly, yes, slightly differently, yeah. Yeah. That's a mammal brain. Right? It's a monkey. A non-human primate. All right, so here's some functions, or three-dimensional. This is a bit anatomical, but so the one on that side, so if you orient to the brain, that's looking, I'm not sure this one's particularly useful, but anyway. At the top left, you're looking at the brain from the side again, and you can see that sort of slice. Corticobulbar, spinal tract, cerebellum, well, it doesn't really matter. That's just showing that would be during a kind of movement because it's got a lot of cerebellum. It would be monitoring sensation. Corticobulbar, who knows, could be anything. Corticothalamic, so that one on the top right. Oh, no, I don't think it's not related to a function. It's not related to a function. Maybe this one, I don't know if you can see. This is, let me think. Corticospinal, so I mentioned that before. So from that motor cortex part, the strip in this part of the brain, where my hand is, both sides, it's the motor homunculus. And the neurons there are the ones that are responsible for the final button press to move, for voluntary movement. This is only voluntary movement. And then all the bundles come together and go down this one super highway into our spinal cord and then to tell the muscles of the body what to do. So that's just one side. So you can see how many, and that's moving a lot of things, right? It's not just one movement, but it's motor function of the trunk and the legs is red, and orange is the arm and hand. They're closer together. So I'll show you a picture of the homunculus.
And they look like there's more hand and arm than trunk and leg.
Yes.
Crikey.
So what are we thinking? Didn't I tell you?
Yeah.
The hand takes up a lot of territory. So see that fan shape? That's how big the territory for the hand is compared to the trunk and the legs. Right? Orange up the top. So we're just looking at A, just A across the top. B, green. That's that's just the corpus callosum showing the sort of interconnectedness between the hemispheres. So this thing about, you know, your left brain or right brain, it doesn't make sense because they're talking to each other all the time. You know, they're just talking to each other all the time.
But unless you're creative,
But it just makes
It's a conceit. It's a conceit.
I love the word conceit.
It's a conceit.
It's so precisely what it is.
Yeah. Yeah.
Is that connection more maybe about the firing or the electrical connection, the left-right, rather than actually having left-right, but just the firing isn't as good on some people and sometimes?
You know, we're all good at some things, and how that manifests in the brain is not particularly well understood. So, you know, the hemispheres are specialised. So for most people, language is in the left hemisphere. That's true. For most people, spatial processing is in the right hemisphere. That's true. But other people, it's flipped. And how specialised one hemisphere is in another is a little bit variable amongst people. So it is true that there are differences between the left hemisphere and the right hemisphere, but it's not like one lights up on its own, which is kind of the conceit around that used to have. People used to think in the 80s, oh well, I'm very left hemisphere, and oh no, just don't interrupt me, I'm being very right hemisphere now. That's like, well, yes, it doesn't. The brain just can't work that way, all right? Unless you've had a corpus callosectomy, which you can have, people have, and they still function. They just have troubles with certain things. The bottom one, don't worry about. So that's sort of specific functions. What else have I got? Oh, okay, so this is language and speech. So this is a specific function again. So you can orient yourself the sort of nose forward, see the ear there. So there's two areas for speech and for language. So one's the motor part of like speaking, the movement of speaking, that's speech. The language is the understanding of the words itself. So this is a 3D rendering of a language network. So those red bits are the sort of cortical areas, what it's called region of interest, left and the right. So you can see, even though I've said language and speech is specialised in one hemisphere, they're in both, right? Yep.
I just want to share on that
Yeah.
point that if you look at my son's MRI, he specifically doesn't have that. And so for that reason, the doctors were always certain that he would never speak. And he has been speaking for a year and a half and has exceptional speech. And they're absolutely puzzled because it's very evident on the MRI that that's not there. So it's pretty fascinating.
The brain can be extraordinary, yeah? And that's that under extraordinary conditions. So who have made the point about are we all wired up the same? Yes, up to a point, because everybody thought that the visual cortex was wired up for vision. It's called the visual cortex. But when they started to be able to, image during a function, people who have been blind from birth who've never had sight. There's a lot of territory sitting doing nothing. So it's when they read with Braille, so when they are processing a sensory input, which all of us would process here first and then buzz it around in the association areas, they're processing in their visual cortex. So it's extraordinary circumstances when these things happen. Like you and I wouldn't do that. Yes.
People are called peripherally deaf.
Yeah.
Their so-called hearing areas of the brain will basically become more visual.
Yeah.
So they become more a larger area.
Yeah. Yeah. Now, if you and I get deaf now, like let's say, I don't know if you have to imagine it, I am, my auditory cortex is unlikely to be that plastic. It's not an extraordinary, because it's already been busy with the hearing for a long time. Yes, that's right. So it's these massive regional shifts of function occur under these extraordinary circumstances. But the point is they can occur. And with children, I mean, there's these bizarre, even the most sort of cynical neurologists have to admit there are extraordinary images of kids' brains with just this thin rim of cortex, these great big fluid-filled ventricles. And nobody knew there was anything wrong with them until they had their brain scanned.
The 90% the French guy that they've been doing research on for 10 years who doesn't have 90% of his brain. I was just reading an article last night.
Yeah.
And all the words in the article, the discoveries they're making of this guy who does not have 90% of his brain, I can share it with the group. Fascinating.
Yeah.
Feldenkrais's words.
Yeah, yeah.
Extraordinary when you
Yeah,
read it.
yeah,
Like,
yeah.
This guy was really ahead of his time because the
Yeah.
discoveries they're now making with this guy that has 10% of brain. It's
It's,
extraordinary.
yeah,
It's completely
yeah.
functional.
Yeah,
And they're like now just saying, well, we actually know nothing about you.
yeah. Anybody who says they understand the brain, tell them bullshit.
Well, you got to go first, yes. So then with this, like if you don't have it, that's it. You don't have it in a different part. It will go like create or work out like that. Like it'd be like if you don't have a hand, you don't have a hand. So it's not like its cells can grow. It's not like they can learn to create a new line.
Yeah, they can.
Yeah, they do.
Yeah, they do.
Okay, so it's not
Yeah.
such a silly question.
No, it's not a silly question. That's why I'm frowning at you, because it's not a silly question at all. It's what they do.
So they actually like when it was
Shh. Yeah.
Where something didn't entirely exist at all, it can grow a physical thing.
Oh,
It
no,
can
we
just
don't
use
make
a
new
different
neurons as
part.
such. Like everyone gets very excited about this thing called neurogenesis, like we make new neurons. And they've found that we do, but there's still no evidence that they become functional in a human brain yet. But the neurons that are there can rewire differently or make new connections.
Oh yeah, I knew that they could
Yeah.
do that.
Yeah.
I just wondered if they
So
could.
you had a brain tumour benign that was removed.
Yep.
And so that left you impaired. I'm just asking, say, about brain trauma, like from a damage or like a tumour removed benign. Would you, and so it's been taking up space, would the area then regenerate, or say if you couldn't walk, can you get to walk?
It depends. It depends on how quickly the tumour grew and what damage to the actual brain tissue happened.
Right.
So if it's a lot of brain tissue damage, like dead damage, like killed damage, that's not going to. You might somewhere else might help to take over some of the function. What can happen though with a slow growing tumour, and I can use an example from my sister-in-law who's had a meningioma removed a couple of days ago. It was growing, so a meningioma is the covering of the brain tumour pushing into her frontal lobe. So she's always been a bit moody, right? You know, I can say that. I'm not looking at you, Dan, but looking at the tape going, is she ever going to listen to it? No, she's not.
Yeah.
It's been getting slowly worse. So it's a slow growing meningioma. And I hadn't seen her for a while because I was away and they were away. But she became almost averbal, like non-verbal. And it was just the pressure on the brain. But it was a temporary obstruction of brain function. So they put her, when they found out what it was, put her in hospital, gave her meds to reduce the swelling. Her speech came back almost immediately. So it was a temporary squash. It wasn't a lot of cell death. And now, of course, they're watching like a hawk to see how much cell death there was from the pressure, because you don't know.
Because
That's my long answer.
One,
you don't know.
It was a large one, growing for over
Yeah.
25 years. So
Yeah.
he was actually, it was on the
Yeah.
frontal lobe. He, you know, intellectually and everything, he
Yeah.
was absolutely fine.
Yeah.
He just couldn't walk very well.
Yeah.
And, you know, that could have been from other reasons like heart condition and that.
Yeah.
So I think
It just depends. It really depends how quickly it's growing and what area it's pushing on. And if it's slow, the brain it will accommodate and it'll kind of move aside a bit and go, all right, well, I'll just keep quietly going here. I don't want to spend a lot of time on this, so just one more. Oh, you. It was Trish. It was Trish. Sorry, to be fair. I'm not sorry, just be fair.
So my question just was around this question of plasticity.
Yeah.
And because in my evil social science world, they have all this, you know, economists drawing graphs about how you invest in children at an early age, because after a certain time their brains can't change. So if they've got criminal tendencies, you're lost, that sort of thing. So from the neuroscience perspective, is there any point where the brain stops being neuroplastic? No.
No, with development, and there's a long talk about development. There are critical windows where it's harder to develop things. So it's harder to develop language, speech and language after a certain period. And you've all felt that, right? And maybe you've had kids, you know, your kids, or when you're a kid, you're exposed to 2 languages and you just picked up languages like that. So there are critical periods where it's easier to learn, and substitute learn for neuroplasticity. That's all it is, right? It's not magic. And memory, learning and memory. That's what neuroplasticity is. So it's easier to pick up some things in these critical periods. But I can still learn a different language. I'd just be pretty crap at it at my age, but I can still learn it. Now, and this is the Feldenkrais question, when is a habit so entrenched you can't stop it? It's a $64 million question, right? Depends on the habit. So if your habit is that you want to go and kill people all the time because you're a sociopath, you know, it sort of sounds a bit facetious to call that a habit, but if that's how you're kind of wiring yourself up to behave in the world, how much that can change or not is the $64 million question. Because there's so many factors in how any of us would change a behaviour. You know, even if it's you pick your nose in public, it's an antisocial behaviour. How can you stop that? Can you learn to do something different? And, you know, do you know what I mean? It's a sort of spectrum. So the spectrum of behaviours and how easy they are to change is actually what we're exploring on the floor. And some things are much easier to change than others. So, you know, walking patterns, you know, general personality patterns, they're hard to change. They are hard to change because they're so intricately wide and we're so well rehearsed, you know, and everything's feeding into that pattern of behaviour. So to unpick it is quite, you know, it's complex. But to give up on people, you know, that's terrible, isn't it? Mm. And there's no neuroscience to back up giving up on people.
I remember back when I was in neuro rehab, there was some sort of, and I didn't see it for myself, but I'd heard that like certain races have a speedier rate of recovery, like say with stroke. Like, is that true? Like Asian, no? So that's not really it.
So there's no doubt about it that younger brains make synapses more, and they make it, this is getting into a long talk now, but so there are two big periods where brains make synapses like you wouldn't believe around, and I'll tell you the ages and you'll tell me whether you think it's functional or not. 3 to 4 and, you know, in mid-teens. And what's their behaviour like? Really shit. You know, like they're just all over the place. So after those periods, they do what's called synaptic pruning. They start getting rid of. They've got too many connections. They're just mental, just all over the shop. Yeah, there is a reason for these behaviours. So making lots of synapses is not necessarily a good thing. And it's absolutely true that as we get older, we don't make as many. But I would like to put my hand up for the ageing people. We get very efficient with our synapses. You know, our pathways are very efficient. And so we know what we want to learn. So there's other aspects that kind of counteract that sort of physiological neuroplasticity, you know, that physiological capacity to make synapses. That's because I'm a bit, you know, putting my hand up for aging because I'm heading that way. Mum, we're all heading that way.
But in particular, like in regards to like race.
There's nothing about race.
Nothing.
Never heard
any. Oh, okay.
No. Yeah, never heard any.
It does sound like a 1950s. I've heard of it.
Cultural, yeah. There might be cultural influences about beliefs. As you know, that I'm just repeating what Joel said around your belief that you can change or learn.
So does that mean for teenage boys on the computer all the time, they'd be shedding or they'd be just strengthening those synapses and shedding other really good ones?
and maybe, I reckon, you know, maybe it's just a good thing that you just keep them out of harm's way, locked in their bedroom. I think it's probably quite a good thing.
At least you know where they are.
I reckon that's probably, I know this is a whole other sort of, but you know, you wanted to see pictures. Let me just see if there's anything else. Now that's actually not a brain, but it could be a brain. It's a cluster map of technology companies, but it could be. Yeah. So, and why I had these, this is for a different workshop. This is a 3-day workshop. That's why I'm hurrying you. To show that in this kind of, you know, you wouldn't expect a hierarchical level of organisation looking at that network either. That network, that pattern of communication, that's what we're talking about in connectivities, patterns of communication, patterns of interaction. So this is a social network, and again, this is the way they think. This, the social networks kind of recapitulate how we currently think the brain's network. So again, there's no hierarchy here. Now, you would say that Larry, which makes me laugh because he is a bit of a social butterfly. My friend Larry, who you haven't met, who's met? Well, you two met. Bev's met Larry. Larry Goldfarb. So you can see that Linda and Larry, they have some degree of centrality. So they have more connections. So Larry's got 1, 2, 3, 4, 5, 6, 7. Yeah. So, and there's we don't know about quality or anything there, right? And Felicia, it's not to say that she's not important, right? So that's a social network, but that's the way we sort of think about the brain. Because that's different, right? That's a leader and a follower map. That would be more hierarchical, where there is a boss in the brain.
And like Melbourne's public transport system.
That's the hub and spoke model. We know from SA Health.
Of the brain.
It can work under certain circumstances, right? But it's just not. You can see that the brain cannot work like that. There is not a controlling centre in the brain that is supreme or dominant. So that's a different kind of map. Now that's, you can tell what that is. That's Twitter, but this is a small world modelling, and this is actually very close to how their mathematicians and the cognitive neuroscientists are working more around. So here's, let's say, all these different little regions of the brain and how the interconnectedness between them. And then they talk about, so this is obviously, in the Twitter account, these people are often communicating a lot, but then there's these long connectivity, connectomes, as it were, and then there's the short ones. And they've actually started to map different brain functions like this. And it's a while since I've been reading into this, but that small world kind of connectivity changes, like with Parkinson's or Alzheimer's or so on. They can actually model it differently. Okay. So that's another way of looking at brain function, how all things, so many things interrelate with so many other things. Yes? And so you can see again, there's no hierarchy in that. There are tendencies and habits, and maybe these are efficiencies or maybe they're not, but you can actually see that level of communication. And then that's the brain itself. That's a stylistic connectivity map. And again, you can say, oh, well, there's a lot of things going through here. This is probably something like the thalamus. Everything goes through there. But it doesn't mean it's the boss. It just means that, things pass through there. It's like Grand Central Station, right? And it doesn't mean that these sort of outlying, so they have a less of a degree of centrality, are any the less important. Does that help?
Yeah. It's radical.
It's radical. Yeah. Oh, you don't need to know about that. That's the boring part of the brain. There's this one other thing I wanted to, because I'm so visual. I've been talking about this one. So do you remember I said we did an experiment, that dominant hand lesson that you were doing, this one with the turning around? You taught yourselves a million times swinging your hand around. So we used that lesson very specifically in an experiment a couple of years ago with uni students. And one group, we taught that lesson, when I say we, I did, taught the lesson on the dominant hand, the other one on the non-dominant hand, the other group, and then the third group did a relaxation sort of sham thing. And we measured them before and after, the three groups. And the group, we thought that the people who did it on the non-dominant hand would get more dexterous, so more able to pick up things quickly and be more accurate with their fingers. And we got them to write before and after, and we timed these movements, all this sort of stuff. But actually, the people with the dominant hand improved the most. Their so-called dexterous hand got even more dexterous, statistically significantly more dexterous, let's say. But we were interested also in how they described the sensation of their hand afterwards. So, and I've been banging on about this when you thinking about the language that you want to use when you're setting up your scan, when you're as ATM teachers. So now all these students were naive to Feldenkrais. We didn't explain to them what it was. We just gave them basic principles about don't do too much, go with ease, blah, blah, blah. So they'd never done an ATM before, and these were the descriptors who did ATM. And you can see, look, lighter and heavier. So this is a word cloud, so that the bigger the word, the more people said it. So the most common responses after that lesson, compare your hand that you were moving with the hand that you weren't, was the question. How does it feel? So the predominant one was bigger. So that's kind of a sure thing. People might feel a body part bigger. However, look at this lighter and heavier, sharper, duller, tired. So they were naive, so some of them overworked. Throbbing, some of them are not as limp, relaxed. So some say more tired, restricted, more active, sleepy, tighter. We could have probably clumped them a little bit better, but we tried more sensitive. This is spontaneous comments. No warmer. Some people said smaller. All right. So to predict what somebody's response is going to be like is quite difficult. So you can predict up to a point. Bigger, heavier, lighter, sharper, duller, maybe.
How did that correlate to predictions?
So the people who did it on their dominant hand, and then we asked how different does it feel from a scale of 0 to 10, they felt more different. And then we got them to write before and afterwards, and the people who had the biggest changes on the accuracy tests also reported that their writing was easier, more likely to. So it, that's just that one lesson that most of you taught. Is that helpful? So the descriptors are very broad, and you can be confident that there can be a change. The direction of the change can be different for everybody. Yes?
Was there any transfer to the non-dominant?
Thank you.
Not statistically, no. The people who did it on the non-dominant hand, they also improved, but not as much. That was opposite to what we thought.
Yeah.
People who did the relaxation class, nothing changed at all. And was there flow from? No, not significantly.
Mm-hmm.
Yeah.
Thank you.
Yeah.
So in
Pain in my life. One more question.
the focus of your question, was it qualitative about the quality of difference and differentiation? Because most of those are like, they're comparatives.
The question was, how does your hand that you moved during the lesson feel compared to the other hand?
Okay, so there is a comparative. So what you're actually promoting isn't how much in a quantitative sense, but a qualitative sense of there is a discernible difference, and this is what this difference is like. So that's one of the things I like in language about Feldenkrais, that it does that.
Yep. So, and we had the data about the accuracy stuff, which is, their overall level of dexterity from the timed things. All right, so that's it. Yeah. The magic word was real quick. We'll say we're going.
I'm just curious because just on that about the dominant hand, and that seemed to be more like the outcome was more effective on the dominant side.
Yeah.
Is that why Feldenkrais did most of the ATMs on the right side, because most people are right dominant?
Possibly. Yeah, maybe. Yeah, but it would be great to ask him.
Yeah, maybe I'll think about that one.
Yeah. Yeah.
Then would we say do it on the dominant side rather than do it on the right side, or house left-handed people?
Well, you're such a minority. Sorry.
I think I'm going to start doing.
But
left
care
side
factor
from
about
now
you
on.
left-handed people is pretty small, Simon. You're just a mutant. So what do we? You're going to die out. Because he was too poor to get a left-handed guitar. Isn't that what I heard? Couldn't afford it. Because he was left-hand dominant. That's why he had to do it. He followed his function. That's a wiring that is really hard to change, right? If you are dominant left-handed and you try and become dominant right-handed. So I've had quite a few clients who were forced to do that because they were good Catholic girls and boys, and the left hand was the devil's hand, Sinistra. And as children, they were forced to be right-hand writers. And they're stuffed.
He's really weird because he plays squash left-handed, tennis right-handed, cricket left-handed, throws on ball right-handed. There's all this, and it's just whoever taught him that thing at that time.
He copied.
Was how he learned it, and that's how he does it.
Yeah, and look, inner people are plastic and they can do that, but I've worked with people who were forced to do it, and it had all that cultural overtone around the devil's hand and stuff, and they are spatially stuffed. That's why they were seeing me.
I grew up with a mother like that, and I'm partially spatially stuffed. I learned from you.
Can I ask you to weaker on both sides?
Another
Should you
big
focus
care
on that
in
side?
school before.
Well, I was converted at primary school.
Sorry?
I was converted at primary school from left to right when I was 5.
You were forced to?
I was left-handed and I was made to be right-handed, and
you're not
I've been an architect. So I think, again, it's really unpredictable.
It is.
I mean, I would say that my ambidextrousness is something I kind of value, and maybe for some people it's stuffed for all kinds of reasons, or, you know, it was more of a trauma, or I don't know what, but
it was traumatic. I mean, they were hit, right? So there's a lot of cultural stuff.
Probably I wasn't getting hit, but you know, I think it's so unpredictable, and I think one of the things that's really fascinating, and I don't know if you think about that, is, you know, there's this idea about sort of heuristic knowledge and understanding, which is that kind of common sense notion or analytical way of grasping the world and communicating with the world. And then there's the other side, the kind of thought intended way. And we have a neocortex, which is thinking and analysing, and then we have these other parts. And I mean, I just think they're both happening at the same time. So it seems to me that if you're saying, my hand feels bigger, and another time you might say my hand feels smaller, this could be to do with how much you're allowing your analysis to, you know, what you think, to colour how you make an understanding. And, you know, I think that, well, I just think it's we're not going to get black and white answers, I suppose.
We're not going to what?
Get black and white answers.
No, we're not. No, we're not. And if I ever come across as black and white, I'm just getting too simplistic, because it's not black and white. And we choose to break things up into movement and thinking and this and that and the other and feeling, but actually what your experience is on the floor. These things are so interconnected, and why I like those images is that you can see that they are, and that the moving and the thinking are not that different. So, you know, for example, the cerebellum, which everyone thought was all about movement and integrating sensation for movement, postural tone and all the rest of it. People who have cerebellar degeneration, their thinking gets slow and incoordinated.
On the other hand, there's
Hello?
this fellow...
You know, like that's thinking. The movement of thoughts gets stuffed up, right? So there's not like neocortex is just about thinking, and the back of the brain is, you know, cerebellum is about moving. The more we find out, the more these things support each other. And cognition, thinking, is based on a fundamental neurological substrate of moving, you know, because our brains were originally mostly good at moving.
So on the other hand, that fellow John Pepper, who has had Parkinson's for 25 years, has sort of overcome all of his symptoms. He thinks using, you know, the way that you can like swallowing, you can swallow autonomically, or you can swallow by deciding to, that he has used that capacity to override, to get
certain parts of the brain. Yeah, so that you can functionally reorganize, or you can do things. So most of the therapies with Parkinson's now do something that's quite opposite to what we would do with anybody else, is that they teach them to not be goal directed, because the basal ganglia is about goal and reward, and that's what's degenerate in them, or hasn't got enough neurotransmitters. So if you take a goal and reward out of it and they just think about moving their leg like you would do in an ATM with no goal in mind, they can do it. Or you entrain them with a rhythm and they can do it. They can walk with a rhythm. Or you put a visual cue and they can do it. But if you say get up and walk, they'll festinate and stuff around. So you can teach them to bypass that deeper basal ganglia need and go straight to the motor cortex, voluntary, not goal-directed, actually, just the motor cortex itself, and then they can do it. So, it's extraordinary. One more question.
So with research like you've done where you check the hand, you find out that it's not what you thought, like we say, a lot of the lessons are on the right side, but you potentially have this new research that says, well, maybe it's better just to use a dominant side. Or
No, I'm not saying that.
I know,
actually.
but what my question really is with further research on the brain, is Feldenkrais really open to like pushing it further with whatever knowledge comes about? Because I imagine that Feldenkrais, if he could have seen the brain, if he could have learnt more, would have continued to enhance the... Maybe.
He would borrow knowledge from wherever he could and whatever science was around. And that's why he talks about chronaxes and all that sort of, electrophysiological stuff, because that's all that was around, and he tried to make sense of it. But sometimes he contradicts himself because what he felt in his body was different to what the Sherrington people were saying, the hierarchical and reflex people were saying. So he would kind of buy into that a little bit and talk about reflexes, but actually he didn't, because his experience was a bit different. So what he would make of all this is a really interesting thing. And one of the other, it's not colleagues in, I don't know whether they did it in Israel or Europe. Anyway, they are Israelis. Well, the Feldenkrais practitioner is an Israeli. Have you done the book on the foot lesson? No? So, anyway, so let's just say if there's a lesson where we apply false floor to the foot to give the illusion of being, your foot is on the floor, but it's actually on a book, in an FI situation. And she did that on people who were in an fMRI and mapped their brain attentiveness, as it were, so what was lighting up, let's say very simplistically. And she did it with two different intentions, which were blind to the person in the MRI and blind to the analysts. One, she just moved their foot with the idea of moving their foot. And then in the second condition, she moved their foot with the intention of sensing how the foot connected to the knee, hip, trunk, not the neck, because you can't move your head when you're in fMRI. So, and the brain responses were different. So the intention of the practitioner in terms of what they were moving and then what the person was paying attention to from a neurological point of view were different. And I think that would, Feldenkrais would go, yeah, of course, I know that. I think he would just say, yeah, of course, I know that.
Yeah, but I feel like I can't remember which book I read it in, but I did read at some stage that he said, people are going to know so much more in not very long, and I really hope they take this and develop it further. Yeah. So.
And I think in some ways he would be disappointed that we've kind of stayed more in the health realm, but maybe not. I don't know. What's the history of people who start a new thing and they don't, the disciples disperse and they get really pissed off with the disciples because they take it in different areas. I don't know. So who knows what he would be thinking. But it would be intriguing for him to hear, teachers taking this into the classroom and taking it into a different kind of learning environment, taking it into the performing arts, like my colleague who runs creativity workshops using Feldenkrais for her fellow fine artists about, creativity. There's a couple of speech pathologists in the Adelaide training, one in particular. She uses this for cognitive retraining, not cognitive therapy, but like in terms of attention. So people who've had head injury, how they can sustain attention and then divide attention, which are things that can get lost after head injury and trauma. So the movement of attention is what she's interested in. So I think we should be inspired by these other stories, and we kind of set up the training to, but I'm already hearing on the board, you're thinking more laterally about where you're going to take this, you know, and how you're going to use these principles in other areas, even if you don't overtly put the Feldenkrais badge on it, but if it influences the way you listen to people or the way you interact with your children. Heaven help the poor little buggers. No, I won't tell you a story. That's too damning. No. It says bad things about me as a parent. You know, go for it. I think he would be intrigued about where people could take these principles of learning, because, you know, life is learning, isn't it? So if it's about having a more complete and kind self-image of yourself, then everybody could benefit in certain ways. If you want to get philosophical, I think we better end the day there. Right, thanks for your attention, and we'll see you next time. Oh, do I dare take another question? All right, quickly. I'm so weak. I'm weak. I'm just weak. I'm weak.
Just about attention. Because it's been really sort of throbbing in my mind all week.
Attention does throb in your mind, doesn't it?
Attention, you know, I haven't got the language. So you can say things like it's magic. You know, paying attention to somebody is very significant. And that's, you know, I think that's a big part of what we do.
It is a huge part, exactly, yeah.
Just in itself, it seems to me to be, well, something I certainly don't understand. I don't know why my giving attention to Karen, this is all purely speculative, seems to make Karen able to think better, feel better, move better, whatever it is.
Yeah, I think this is... in the trainings, we've been very good at the self-observation stuff, and I've hinted at this a lot. A lot of us are now getting very interested in how this connection between people, as well, I've got so many workshops on connectivity, I guess, is that how does that happen? How does one nervous system influence another nervous system like that? It is really interesting. And what, you know, our experience of really being seen, or really being heard, or really being touched in a way that's not judgmental, or, you know, that feels safe, that feels, you know, curious, and all those qualities that we keep talking about, you know, in terms of the learning principles, or what makes a learning environment. How come that has such a profound influence on another nervous system? I think it's a marvellous question. You know, I think there's a lifetime of exploration in answering that question, isn't it? You know, and that's what you're experiencing. So even though, you know, I was talking to somebody about, you know, who maybe not particularly be interested in actually doing FI, there's a couple of you. However, there's something in that interaction that is very enriching. Just to experience that, even if you're not going to use touch, you know, in your future lives, well, you're going to have to touch somebody, maybe not, I don't know. But it's about, you know, just using another medium to connect with another nervous system in a way which helps you explore that kind of interaction in a way that's extraordinary. And for those of us who touch for a living, you know, like coming from a profession that touches in a very different way, it's interesting. So, you know, I often think to myself, you know, when I'm in sort of physio mode, people come to see me for physio, that's what they get, because I don't mix up the two too much. Well, I have to, but I don't.
Mix up. You've only got one brain.
No, you can. It's a different way of thinking. Because I've got many different lenses of the way to look at the world. Yeah, if someone wants to be fixed, you know, if they want physio, they want to be fixed up to a point. So then I push on their spine. There was one guy, this guy came, he's a surfer, right? And he, I don't know why I sees a lot of surfers. And he was saying, oh, you know, I don't want to surf anymore because I get this pain. I said, when do you get the pain? And he only gets pain when he does this. And I gave him these great lessons, and he'd change, you know, and he was sort of, you know, sort of stands like this, and after the lesson he was standing like this, and, you know, big changes, 2 massive big FIs, but still gets the pain when he does this. And I did say to him once, could you just maybe not do like that? Anyway, in the end, my physio skills are not very good, but I just did this manual kind of mobilising on one little joint, and he got up and goes, oh, that feels fantastic. I haven't seen him since. So, you know, whatever. What was it? Anyway, touch. So play with it. Yeah, you know, play with interaction. Sometimes, you know, that he didn't want to be. What changed him wasn't this inquiring, beautiful felty touch. He just wanted to have his, you know, was about L4 prophyceal joint push really hard, like that. It was very, you know, who knows. So that's the thing is, yeah, we've got a lot of lenses to work with, and it's about using them with a choice. Judicious is always my favourite word.